Hey guys, today's question is design a number container system. In this question, we have to implement the class number containers in which there are two functions, void change and int find. So what change does is the number and index are passed. So the number passed is placed as the index passed. Okay. Like for example, if 2 comma 3 is passed, so at the second index 3 will be placed. Okay. And let's say we are again passed with 3 2 and 4 2, so it will overlap at that index. If the index is repeated, the the number which came at the last will be at that index. Okay, so it will simply overlap if the index is repeated. Now in the end find, what we have to do is we have to return the smallest index in the structure in the class, which where the that number is present. Okay, like for example, if we call this function 3 times and let's say we passed 5 2 4 2 and 3 2. Okay, so for number 2 there are three indexes in this structure. Okay, 5 4 and 3. So what the int find will return for the number 3, sorry, number 2 will be 3. Okay, because it was the smallest index where 2 is present. Okay, 3 is present, sorry. So what we can see is, to find the smallest index at every point, smallest or maximum, what we do is we will simply use a ordered set or a priority queue. Okay, so we'll simply use a priority queue for that. But what another thing is that if a number overlaps the previous elements, like for example, if 2 comma 5 is passed, okay, and then 2 comma 4 is passed, so the number 4 overlaps the number 5. Okay, now number 5 is not present in that array, or if it is present at any other index. So what we will simply do to tackle that point is we will use another hash map, uh, simple hash map, which will tell at what index what number is present. Okay, because at one index only one number can be present. Okay, but at a number there can be a multiple indexes. So for that we will use a hash map of the element and priority queue. Okay, because we need to find the smallest element always. And when we will find the smallest element, we will simply check if that index is if that index on that index that number is present or not with our second hash map. Okay, so let's implement this to understand more. First we need to maps. So let's take unordered maps. First one for the number and its indexes, and there can be multiple indexes for the number, so we will use a priority queue because we have to find the smallest index at every point. So priority queue of integer, and now we have to take a min heap. Okay, minimum priority queue. So let's write this vector int, so greater int. This is the format for the min heap. Okay, so this is a min heap. So unordered map is for the index and the, sorry, number and the indexes, which will be in the min heap form, and let's name is name it as mp. Now another unordered map which will tell at what index what element is present. So unordered map int comma int. Okay, let's name it as mp2 this time. And now in the function we don't need to change anything. If the change function is called, first we will check if the already the current element present at that index is same. Okay, like for example, if 2 comma 3 is passed in the change and then again 2 comma 3 is passed, then we don't need to change anything, otherwise it will cause a problem. Like if we have two same values in priority queue, that will lead to an error. So first we will check if mp2 dot count index, okay, if mp2 have a value at that index and mp2 of count is double equals to, sorry, mp2 of index, at that index the same number is already present by a previous call. Okay, then we don't need to do anything, we will simply return. Okay, and wait a second, in the else case what we will do, we will simply mark that index to that number. Okay, so in the second map, which is the map of index to number, we will simply mark as mp2 of index equals to number. So it is the latest index for, so it is the latest number for that index, and also we have to push in the queue. Okay, in the priority queue, so simply mp of number, for that number we are pushing, so dot push, we are pushing the index, so index is passed. Okay, as simple as that. Now in the find, first we will have to delete those elements which are not present, which are not at the current index. Like for example, if the function call is made for 2 comma 5, okay, at the index 2 5 is passed, and then 3 comma 5 is passed, okay, nay, let's say, and then 2 comma 4 is passed. So at index 3 there is no more element 5, so for this that number 5 you have to return -1. So what we will do is we will delete all the elements in priority queue which are not at that current position. That's why we use this map, okay, mp2. So we'll use that map. So simply we'll run a while loop while the queue is not empty. So while mp2 of number, which will the priority queue for that number in the map, while this is not empty, we will simply check, okay. First we will find the index. The index, it's as simply the top, okay. mp, the smallest index we are finding at every point, so mp of number dot top, this will get the smallest index. And if this index is not related to this number, okay, if any other number has overlapped it, so we will simply check, okay, if mp2 of index double equals to number, that means this number is already at its correct position, okay. At that index only that number is present. That's why I use the second map. So we'll simply return that index because it is the current index for that element. Otherwise we will simply, in the else case, we will simply pop, okay. So mp of number dot pop the value at the top of the queue, and if this while loop terminates, if the queue is empty, then we will simply return -1 because as given in the question, if there is no index, then we have to return -1, okay. I think that's it. Let's run this. Okay, sorry, it should be mp of number. Mhm. Okay, I took it as idx, not index. Okay, now it should run. Okay, let's submit this. So the code is accepted. Thank you for watching.